Next topic is the analysis of external reaction and internal stress resultant of statically determinate structure. And the first one here, the first structure we are going to discuss is the beam. Ano ba yung mga internal stresses? Okay, before kita ngadtuhan an beam. Di ba beam, maram naman kamay beam. Hindi lang kita hikuan. Hindi lang kita simple stresses. What are the different types of simple stresses? Anyone?
Tension.
Tension is not a stress. Bangin tensile stress. Tensile stress is a stress, pero tension is not a stress. Okay, there are three major types of stresses, simple stresses that we have. What are those three?
Tensile shear.
Tensile shear tapos compressive, sir.
No. Tensile and compressive belongs to a single type of stress. There are three major.
Bearing.
Bearing, of
Normal
course,
stress.
number one.
Bearing stress.
Okay. We have the normal stress. Diba? Normal stress. Okay, normal stress or sometimes called as the axial stress. Okay, number two, ano pa? That's shearing stress. Okay, shearing stress. And the third one is, ano sunod?
Bearing.
Bearing. Okay. Diba? Bearing stress. Of course, dapat maroon kami kay first topic inihan. Strength of materials. These are the simple stresses. Diba? Ang tensile stress and compressive stress, dito niyat normal. Duduhait normal, may da compressive stress, may da tensile stress. Ang shearing stress naman, may da induced shearing stress, may da direct shear stress. Okay, direct shear stress, tas induced shear stress. Ang bearing stress lang. Okay, simple stresses inihera. Now, may da kita gyap sinisiring flexural stress. Familiar ka mo with flexural stress?
No, sir.
Di ka mo familiar. Oh, let's call it another name, bending stress.
Yes, sir. Familiar na po, sir.
Familiar ka with bending stress. Pareho iton hera, flexural stress and bending stress. How can you solve for the value of the bending stress? How do you solve the value of bending stress? Anyone? The formula for bending stress. Nakan ka mo familiar ka with bending stress. What is the formula for bending stress? Anybody? To solve, to search pa. Okay, bending stress can be expressed by this formula. Bending stress is denoted by F of B. Diba? F of B. F for flexure. Small letter F for actual flexure. Capital letter F for capacity. Okay, so the flexural stress is given by F of B is equal to MC over I. MC over I. Or sometimes, it iba nga book, ini nga C, instead nga C, Y iton niya. Whatever. Basta for now, it aton pag-denote MC over I. Or, okay, let us explain. Let me explain ano ito niya nga mga M, ano ito niya nga C, ano ito niya nga I. Okay, suppose we have a beam simply supported. And this beam is subjected to a force, distributed force, like this one. Let's say this is W and this is L. Okay? Ano ito niya? Ang cross-sectional area naman, nito nga beam, say this is denoted by B and this is denoted by D. Okay. Ano it moment? Pananglitan. Pananglitan ha. You are tasked to solve for the value of the flexural stress at a certain point on the beam. Okay? At a certain point on the beam. Say for example this point, in a point. Okay. So if you are trying to solve for the stress on that point of the beam, on that section, we call it section, that section of the beam, hindi nga point. kailangan nimo an moment hand beam at that section, di ba? Kailangan nimo an moment of the beam on that section. Amo niya nga M. That's the moment of the beam on the section where you are trying to solve for the value of the flexural stress. Okay? M, moment. Okay, an I, it I is the moment of inertia. I is the moment of inertia of the cross-sectional area of the beam on that section. Okay? So since this beam is homogeneous man, ibig sabihin the material are the same all throughout the span, the cross-sectional area are the same throughout its span. So I will an iya cross-sectional area. So an I, that's just the moment of the area of the cross-sectional area of the beam on that section. So if you're trying to solve for the I here, that is just equal to BD cube over 12. Masahin la, di ba? Take note, it atong ibibiling is the moment of inertia at the with respect to the neutral axis. Okay? May nakita neutral axis. Okay, let me redraw the. Okay. You ask questions if there are concept nga diri niyo naintindihan. Alayon la pakiana ka mo before kita kuan. Okay, this is B for the base, D for the depth. Tas may nakita din an aton sinisiring neutral axis. The neutral axis is of course ada dida hit center. Since this is just a rectangular beam, so the neutral axis is passing through the centroid of the section of the cross-sectional area. Now, ano ba itong neutral axis? The neutral axis is the fiber or the axis ito niya. The neutral axis is the axis wherein it experiences no stress at all. Wala niya na-experience na stress. Diba? Neutral axis. That's why it's called neutral axis. Kaya neutral hiya. Na maintindihan niyo kung kay ano neutral itawag. Okay. Later. Okay. Ang C naman, what is C? C is the distance of the fiber being considered from the neutral axis. Naglilipong net iulo ano. Familiar ba ko? Nasa ring daw, C is the distance of the fiber being considered from the neutral axis on the section wherein you are trying to solve for the value of the flexural stress. Okay. Para maintindihan niyo, I think makulit talaga yung pag-explain. Siyahan talaga. Pero kung mag-grasp na niyo, naintindihan ba? Naintindihan ba?
No, sir. Ansi, sir. Naglipong na ang ulo, sir.
Ansi, naglipong na. Okay. Okay, let me stop the presentation. Let me get. Nakikita ako ngayon? Nakikita ba ako?
Yes, sir.
Yes po,
Yes,
sir.
sir.
Okay. Nakikita niyo yung akong book?
Yes po, sir.
Yes po, sir.
Mag-analyze nga nakita hin beam. We always treat the beam as if the beam is like this book. Okay? So this is the front of the beam. Never mind na lang halapa dit akon libro ha. Pero amoy niya kumbaga it beam parang sugadin it yung pagkita, di ba? Adi ang support, nakita niyo? Adi ang support, tas adi ang isa nga support. Duduhan support niya. Okay, parang nasugadit support. Nakikita ba? Please say yes.
Yes, sir.
Nakikita. Okay. Now, if the beam is subjected to a force, usually it force it beam always man la iton along the y-axis. So kung subjected nga niya to force, di ba, it tendency nagbe-bend, nasugad. Kita niyo? Hindi ko din nakikita. Di ba, may
Kinikita,
danganing
sir.
force,
Nakikita po, sir.
nagbe-bend niya parang sugad. Di ba, nagbe-bend niya?
Yes,
Okay. Nagbe-bend nga niya. Okay, when we analyze a beam, we treat it as if like this this book. May niya mga sheets, di ba? Parang it beam, damo ito niya nga sheets nga gin-stack together on top of each other, parang gin-stack ito niya para maka-form hini nga beam. Okay? So, ibig sabihin, may dani mo mga sheets. Okay? Itawag ito nga sheets in our analysis. We call it, ano, sa nga sheets lang ha, we call it the fiber. Ito naging nakakangin nga fiber. Okay? This is the beam. So, the beam, may niya outermost fiber, adi ang pinakailaro, ngahan pinakaigbaw. Ito niyan iya outermost fiber. Kay ano nga crucial nga i-treat natin it aton beam as if sugad hini may mga sheets nga gin stack on top of each other. Because ipag-analyze natin parang sugad gyap hini. Magbutang ka nga ning load, magbebend hiya, di ba? Magbebend hiya. Uy, kitaan niyo.
Yes,
Masayon
sir.
lahiya mabend. Itiyan nga libro, masayon lahiya mabend because an sheets, an individual sheets han libro, diri hira nakaka-resist han forces. Di ba? Diri may nakaka-resist, masayon lahiya mabend. Now, what do you think will happen if tawag ni i-glue naton ini nga mga sheets? I-glue naton, di ba? I-glue nga nito naton, for sure, makukurean na kita pag-bend. Because now, nakaka-resist na an aton sheets. Diri naman hiya nakaka-resist naman hiya kanginahan waray pag-glue. Parang free hira to slide on one another. That's why madali lang hiya ma-bend. But imo nga ni imo nga ni i-glue,
Glue.
makaka-resist na hiya. Diba? Makaka-resist na hiya. Ibig sabihin, dili lang hiya basta-basta magkukuan nakuha ko daw akong kuan. Wait lang. The background. Okay, get the background. Bakit ang talaga tak background? Bakit di na ako tak background? Apply. Okay. Siya katak itsura. Anyway. Ako pang kasi kung may background, parang nawawara it akon. Okay. Ano to? Na to. Ang sheets free to slide kung waray pa natin ginwaray pa gin glue. Pero kung may na nga ni glue, dili na niya free to slide. That's why makukurean na kita bend, 'di ba? Makukurean na kita pag bend. Okay. Now, makuri naman mag-bend, 'di ba? It matatabo hiton imo nga ni ipar sa pag-bend, 'di ba? Aadi ha ubos ang pinaka outer lowermost fiber makaka-experience ano nga stress it iya ma-experience if i-force naton i-bend like this.
Tensile stress
Showing
po, sir.
tensile stress, di ba? Nate-tense siya. Kaya ano na-elongate man yan, elongate. So, nate-tense. Okay? Ang ari naman habaw-baw, ano nga force, ano nga stress it yan na-experience?
Compressive stress.
Compressive stress. Di ba? Nako-compress siya. Ang aadahabot nga, ang neutral axis, ano it yan na-experience?
Zero.
Zero. Because neither tensile, neither nor compression, it iya na experience. That's why it's called neutral axis. Kaya neutral man hiya. Ibig sabihin, ang stress at the neutral axis is zero. Now, let's go back to the balik kita nga dilihan akong presentation and akong solution. Okay ha? So, maram na ka may fiber. Okay. Now, ano man ito nga C? Okay, didi kita ha. Nayakang kita, when we treat when we treat the beam, it's as if may mga sheets na gin-stack together. May dali mga sheet. Nakikita niyo ito akong solution. May dali mga
Yes, sir.
Okay. Ito nga mga sheets, ito sinisiring a fiber. Okay. So, pananglitan, maya kanit problem. Surat ko ha, find the stress, the flexural stress of the fiber, okay ha, of the fiber, say 200 of the fiber of the fiber 200 mm from the neutral axis on the section 3 meters from the left support. Okay, kita daw niyo. Find the stress of the fiber 200 mm, 200 mm ini ha, dari 200 meters. 200 mm from the neutral axis on the section 3 meters from the left support. Ano ibig sabihin nito? Kita ha. So bari nga kita nga section ada. Nag-mention niya section. Section nga ni ang cross-sectional section. Kung hain hiya dapit didahan beam. It's either this section, or this section dinhi. Kaya kan hiyahain daw nga section 3 meters from the left support. So hain ito nga section 3 meters from the left support. Nga dida 3 meters. Nakuha niyo? Ibig sabihin section.
Yes, sir.
Yes, sir.
Okay ha? Section, ibig sabihin, an kuha niton, kung haing diin dapit han beam, ang iyong bibiling nga stress. Okay, so maaram na kita, 3 meters from this section. So, ibig sabihin, an imo moment, na depende kung hain nga section. Diba? Kaya kan di 3 meters from the left support nga section. So, bibilngon nimo kung ano ang moment itong dida nga section, itong nga particular section. Okay. Ano naman ito? Ibig sabihin nito nga, on the fiber, 200 mm from the neutral axis. Okay, may ka na section ha. Gindrawing mo ang cross-sectional area. Had to dito nga section. Hininila nga section. Adi ang cross-sectional area. Now, say for example, the dimension, the depth is, say, this is 500 mm. And the width or the base is 300 mm. Pananglitan. Ano ibig sabihin when you say 200 mm from the neutral axis? Saan ito nga fiber? Okay, ha? This is your neutral axis. The neutral axis to the outermost fiber in, kailan kita ito nga in compression or in tension. This is the outermost fiber, right? Ini. Amoy niyan, outermost fiber, tas adi diha ubos. The outermost fiber, duduha. Diha bawa, diha ubos. Okay? Okay. Pero distance from the neutral axis to the outermost fiber.
250 mm.
250, right? 250 mm. Okay. Nayakan man nida nga 200 mm daw from the neutral axis. So, haing nga fiber, ang imuging ko consider. Nila din, di ba? Somewhere here. This is 200 mm. Okay. Explain ko nga how ang valuehan siya. C is the distance from the neutral axis to the fiber being considered, okay, on the section where you want to find the flexural stress. Nagets na niyo ang akong definition ng C?
Yes, sir.
Liwaton ko ha. C is the distance from the neutral axis to the fiber being considered on the section where you want to solve or to find the flexural stress. So, ibig sabihin, kung ang ginbibiling nga, kung ang consider nga fiber is this fiber, the fiber which is 200 mm from the neutral axis. Ibig sabihin, ang imo valuehan C is, what's your value of C? Di ba ang 200 mm mismo? Because C is the distance from the neutral axis to the fiber you are considering on the section where you want to solve for the value of the flexural stress. Nagets ba? Nagets ba
Yes, sir.
FC?
Yes, sir.
Kaya?
Sir, antikado ubos, sir.
Yes, sir.
Mga tikadi August, pwede gihap nimo adi nga fiber imo i-consider as long as that's also 200 mm. Okay, wala man magiyakan nga in compression or in tension. Basta 200 mm daw. So pareho la, actually pareho la ito niya it iya stress. Okay, pagkakaiba la. Okay ha. Kita it aton formula. FB, let me put it here. FB is equal to MC over I. Okay. Let's talk about this this section. Okay, pag automatic. Okay, yun. And say this is the neutral axis. This is the neutral axis. Okay. let's talk about this formula. Okay, kita your FB or the stress or the flexural stress or the bending stress is directly proportional to M and C. Okay? Directly proportional to M and C. Ibig sabihin, if C is constant and I is constant, if B will go high, okay, pananglitan constant and C tas constant and I. If B will go high or go up if the moment goes up. Okay? Ibig sabihin, okay, balik kita nga dididi. Balik kita nga dididihan koan. Okay. Di ba maram naman kamo nga if you have forces here, may dani mo nga forces dida. Di ba didtuhan iyo strength of materials, gimpi pinasolve ka mo damuan nga diagram of the ano ba to, diagram. Shear diagram. Di ba mapasolve ka man shear diagram?
Shear diagram and moment diagram.
Moment diagram, di ba?
Yes, sir.
Moment diagram. Okay, and moment diagram, okay, kung sugadin yan imo, this is what we call the load diagram. Okay, mga loads man iton. Okay, moment diagram for this one, masugad dito nit iya moment diagram. Masugad. Okay. As you can see, oops, diri iton sugad. Nasugad. As you can see, dili kita moment diagram makay adi makita hit flexural stress. Later, isosolve natin it, hindi naman kita hit shear diagram if we still have time. Okay, dili kita moment diagram. Di ba as you can see, it moment diagram din for this type of loading. Its usual nga maximum moment can be found at the center of the beam, di ba? The maximum moment can usually be found at the center of the beam or the midspan of the beam. Depende, of course, it iya loading. For this type of loading, ada hit midspan, it iya maximum moment. Okay, take note ha. Nayakan ako didi. If C is constant, if I is constant, if M will go up, if B will go up. Ibig sabihin, usually, all the time, the stress is maximum. Okay ha? The stress is maximum at the section where the maximum moment occur. Nakuha niyo? The stress is maximum at the section where the maximum moment occur. Kay ano importante ito nga mahibaruan niyo ang maximum moment? Kay ano nga dituhan strength of materials? Gimpi pina-drawing kamo hin shear diagram, gimpi pina-drawing kamo hin moment diagram, tas gimpapabiling pa kung hain din ang maximum moment, high and maximum shear. Now, this is the importance. Hiton nga activity nga gimpi pinabiling kamo hin maximum moment. Kay ano? Mabiling mo nga ni it maximum moment, mabibiling mo kung hain it maximum stress, kung hain nag-o-occur ang maximum stress, di ba? Mabilingan mo nga ni kung hain din dapat it maximum moment, mabibilangan mo kung hain ang maximum stress nag-o-occur. Now, what's the significance kung kay ano kailangan mo mabiling ang maximum stress? Okay. Nayakan kita, if you can still remember, di ba, and the design process. Nagdi-design nga ni kita, you're actually anticipating the failure of your beam. Now, if your beam will fail, okay? If your beam will fail, hain diin dapit nga section, an imo beam will most likely fail. Answer my question. Anyone? Anyone? Please raise your hand. Anyone? Okay, Miss Maurice Leonard Sempron. Mr. Sempron, I'm sorry. Mr.
Dito,
Sempron,
dito po sir dapat han part han beam nga pinakadako ay an stress.
very good, di ba? Obviously, kunhain ang pinaka-maximum ang stress. Okay. Kunhain ang pinaka-maximum ang stress, amo itong didaan most likely mag-fail an imo beam if your beam will fail. Okay? Natural, aada didahit maximum stress. And the maximum stress is where the maximum moment occur. Di ba? Amo iton. So, the important, So it follows that the importance kung kay ano gibibilin niyo kung hain ang maximum ang location maximum moment is para mabiling niyo para mag-design nga ni kamo maaram kamo kung paano niyo i-design. Maaram ka naman kung ano maximum moment, maaram ka man kung hain diin ang maximum moment nag-occur. O dapat an imo design dapat you should make sure nga iton dida nga okay, iton the point where the maximum moment occur or the point where the maximum flexural stress can be found, itawag ito naton dida is the most vulnerable section. Vulnerable section niya. So kung vulnerable section niya, di ba, nayakan kita. Nung di-design nga ni kita, nayakan, your design daw is as good as its weakest part. Di ba? Your design is as good as its weakest part. Ibig sabihin, kung mag-fail nga ng imo weakest section, or imo weakest, yes, weakest section, ibig sabihin, failure na tanan an imo beam. So you have to make sure nga imo pinaka-vulnerable section is well reinforced. Well reinforced. Diba? Amo iton, kung matunga kami RCD, amo iton nga usually aada dida itdamo it bars, ada dida it boot nga. Diba? Kay amo ida one of the most vulnerable section. Okay? So amo la iton niya. That's the reason kung kay ano nga di pinabiling kamo kung high location hit moment. So meron kamo waray gamit. Okay. Kaya amo iton ha. So maaram ka na kung high init maximum moment. That's why when I say kanina nga usually di ba nag-specify didi section daw 3 meters from the left support. Usually it problem masaring la ito nga find the maximum flexural stress. Sige daw. Kung ang problem nasa ring find the maximum flexural stress, anit una nimo nga ifa-find? Una nimo nga ifa-find of course is the maximum moment and where is the maximum moment kung hain nga section and maximum moment nag-occur. Diba? So, amo ito, kung maximum moment ang bibiling, so the problem is telling you implicitly that it section na ko consider din is the section where the maximum moment occurs. Baka maximum stress man ang bibiling. Yun. So, dapat maarang ka magbiling kung kahit maximum moment. Okay, now, you already found, nabilingan mo na kung hain and maximum moment. Okay, so you are now considering ini nga section. Pananglitan amo yung nga section, amo yung cross-sectional area, hand section, where the maximum moment occur. So, ibig sabihin, all of this section experiences the same moment. Okay, so pananglitan now, your moment now is constant for that section alone. Okay? Ibig sabihin, kung adding a fiber experiences the same moment, adding a fiber experiences the same moment, adding a fiber the same moment, bisan haing a fiber on that section experiences the same moment. So, ibig sabihin, your moment is constant all throughout this section. Okay? Nagva-vary lang imo moment all throughout the span of the beam. Okay? This is the beam. And imo moment, nagva-vary la all throughout the span of the beam. Pero on a single section, your moment is constant. Okay? Nakuha niyo? Now, since we are now on a single section, your moment now is constant. Now, ano man it C? Okay. Ibig sabihin, if C goes up, since constant man an M, man I, if C goes up, your FB will also goes up. And value, di ba? So, ibig sabihin, FB is directly proportional to C. That is if moment and I are constant. Okay. So, ibig sabihin, hain nga fiber, take note ha, C is the distance of the fiber to the distance of the neutral axis to the fiber being considered. Okay? So, bisan hain din ang fiber. Now, question, hain nga fiber, it pinaka-hirayo han neutral axis. Hain nga fiber, it pinaka-hirayo han neutral axis.
An outer fiber, sir, an upper and lower.
An outer fiber and lower fiber, obviously. Amit pinakahirayo from the neutral axis. So, ibig sabihin, the outer fiber, the outermost fiber, the fiber habaw-baw, the fiber hailarom, amo ito na mga fiber nga pinaka na stress. Ano pinaka na stress ato gawas nga fiber. Okay, so ibig sabihin, okay ha, since kita ada with relationship with F being Hansi, they are just linear, right? Wala man nila mga exponent. So linear light error relationship. So if you draw the stress diagram, masugad dito ng dili. This is in compression. Tapos 0 at the delta axis. Tapos ari naman dili, this is in tension. Since this is just linear, straight line lang ito ni diagram. Okay? Compression, habaw-baw. Tension, haubos. Okay? Amoy hiya ha. The stress diagram. O may nakita kanina, strength of material, may yung shear diagram, may yung moment diagram. Yan na, may nakita sa isa rin nga stress diagram. Okay, now, this is the stress diagram for flexural stress. Okay, bending stress. Okay. So to solve the value of your C here, not to be confused with this letter C. Ini nga letter C, this is small letter C. This is the distance of the fiber being considered to the neutral axis. While the C here is capital letter C to denote compress. Okay, pananglitan na yakan it problem. Find the maximum flexural stress or find the maximum bending stress on the ano. Tas may ginhatag nga kuan, may ginhatag nga may ginhatag nga span, simply supported beam. Okay. Ano it your first step? Kung it ginpapabiling is the maximum flexural stress, the maximum bending stress. Ano it iyo una nga bibilngon? Sige daw, anyone, let me call in anyone, any volunteer. Kung naiintindihan talaga process it, pagpa-find it stress. Waray? Waray volunteer? Okay, sige, waray volunteer. Ako it matawag. Alice, Alison, babae ba or lalaki? Hello?
Lalaki po ito, sir.
Mr. 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 Di ba? Ay, naadto. Mr. I volunteer you. Okay, question. If you are trying to solve for the maximum moment, maximum bending stress, anit una nimo nga iso-solve? Sige daw. Any idea? Hello?
Sir, come again, come again.
Okay. Anit una nimo nga iso-solve if you are trying to solve for the value of the bending stress? Anit una nimo nga iso-solve?
Uh,
Okay, better yet, how do you solve for the for the the flexural stress? Sige daw. Explain daw it imo process. Let's see if you really have understood an akong discussion. Sige, how do you suppose, i-describe lang, I'm not saying that you will actually solve, describe mo lang, and process. So how can you solve for the value of the maximum flexural stress or the maximum bending stress?
uh, I think it was mentioned about the moment, the maximum moment to be find first. I think.
How can you solve for the maximum moment?
Um. I have no idea, sir. Pero the idea is there, but the actual solution is very vague to me.
No. What is your idea? Since you are saying that the idea is there, what's your idea? How can you solve for the maximum moment? We're not taught how to solve for the maximum moment. I think your teacher taught you how to solve for the maximum moment. Is that right, Mr. Okay.
Yes, sir.
Sige daw. How do you suppose you solve for the maximum moment?
First, about the inertia, finding the inertia, I think.
Why do you need the inertia in solving for the value of the maximum moment? You don't need the inertia in solving for the maximum value of the moment. The moment lang ha, since nayakan ka kasi nga in solving for the maximum flexural stress or the bending stress, you need first to solve for the maximum moment. Now, I am asking you, how can you solve for the maximum moment? Kuan lang, the process lang. Tell me the process. Or if you are given with a beam, a simply supported beam, how can you solve for the maximum moment? Paano mo ba maging solve with maximum moment?
The reaction of the first of the diagram.
Of course, the
Yeah,
reaction.
the support.
Very good.
I think.
What's next?
Uh,
Ano ba? Ano ba ito ang iging bubuhat pag solve ng maximum moment?
wait, sir. I'm still remembering the parts. Basta napaka-remember first the reaction of the diagram, and I don't know about if involved an area.
Areahan ano?
Han diagram.
Areahan an cross-sectional area? Anyone? Anyone, how can you solve for the maximum moment?
Moment diagram.
Miss Hermoso. Mr. Elio, thank you. Mr. How can you solve for the maximum moment?
One, first time for the reactions if there are any. Then bagat cut sections and diagram. And then for each section, find for the bagat equations and kanan sharing and moment. And then from there, magkukan ka lang bagat substitution na lahan. Kung makuha na an equations and sharing and moment, but substitute na lang valuehan like x kung amo nimo gamit nga variable. Tapos
Okay.
turuhan imo diagram nga mahihimo makikita man kung hain nga ton maximum.
Okay. Thank you. Okay ha. Naya ka ni Miss Hermoso. Okay, pananglitan, may dakita beam. Okay. Straight iton nga beam ha. There iton kuan. Bear with me na lang. Okay. Pananglitan may natin mga beam din di ba? So gan. Para makuha natin aton pananglitan may di force. God, that's another force here. This is A, B, C, and this is D. Okay, this is A. Okay. Para natin ma-solve, ma-drawing, yeah, ma-solve and maximum moment, of course, you have to solve first for the reaction. Diba? O, may na reaction. Tapos, ikakat mo dida. Di ba nakakano ka mo? Nagkakat ka mo, tapos i-isolate. This is the cutting plane, the shear, and the moment. Tapos, kukuha mo an equation han shear. May dali mo equation han shear, equation han moment. Diba? Tapos, basahin ka naman, if x is equal to 0, what's the value of shear? What's the value of moment? If x is equal to whatever it ada dida, x sub 1, kukuhanin mo ang valuehan g, kukuhanin mo ang valuehan m. Tapos ipla-plot mo, di ba? Amo na hindi yan nga shear moment, shear diagram and moment diagram. Okay? So may mo shear diagram, may mo moment diagram. Di ba? Shear diagram, may mo moment diagram. Tapos gimpo project pa nga nato niyo, di ba? Parang gipo-project na yung nga D, tapos an B, nga D, an C, an D. Okay, tas when x is 0, may mo valuehan shear. Ada. When x is something, madali mo valuehan shear. Say, for example, adi, dida, or something masugad nga di, tas masugad. Di ba nasugad adto? Ani, parang nagsusugad-sugad adto, whatever. Tapos,
Yes, sir.
parang nagsusugad-sugad naman, sugad-sugad pa, what? Basta sugad dito na it iyo moment diagram, shear diagram. Tapos kikitaon nimo kung hain dida it maximum moment. Di ba? Tapos parang lita na adi diyan maximum. Ada dida. Other than maximum. Kukuha mo kung ano nga value. Now, that is the maximum moment. Okay? Of course, makuha mo nga at maximum moment, you also need to solve kung hain ito niya dapit. Ano niya distance from the left or right support. Or bisan diin nga kuan. Bisan diin nga reference point. Okay, so that's how you solve for the moment. Diba? Nagkakat ka lang din tas makukuha mo an equation. Tas next naman, makat ka naman ha point BC, tas makukuha mo an equation. Tas if x naman is equal to blah blah blah, tas makukuha mo an V and M. Tas idodrawing mo naman didi. Diba? Tas after din han BC, adi naman ka magkakat ha CD. Diba? Asya ito na yung pagsusolve. If you can still remember, that's how you solve for the maximum moment. Okay, so equation. May dagyap kita sinisiring na area method. Di ba? May the moment equation method, may da kita area method. Okay, so di ko na i-discuss because kin-discuss na ito hiyahan, strength of materials. If you want to recall, then study ka mo. Kaya ano, didi pala, it ginpapabiling didi, it maximum maximum flexural stress. So you need to solve for the maximum moment. First step pala ito niya, an moment. Tas karada mo ito ng himo, first step pala, di ba? And first step, damo pa nga step an mahihimo before ka maka-arrive an value and maximum moment. So recall ka mo. Okay, so that's the first step. You solve for the maximum moment. Adi step naman pag-solve an moment. Now, what's the next? Let's go back to Mr. Mr. na-solve mo na an moment. What's next? Ada pa ba si Mr. No? Kumuwas na dahil. Hello? Can you still hear me? Nababatian pa ba ako?
Yes, sir.
Yes, sir.
Wala na dito Miss. Okay, Miss Hermo, please continue. After solving for the value of the moment, what's next?
Kuan bibilingon liwat an moment inertia. May da naman maximum nga kuan an moment.
Then, what's next? Moment of inertia, tapos hello. 407 na.
Ano?
Okay. Kay maximum flexural stress man, after finding the maximum moment, you solve for the inertia. What's next?
Divide.
Ansi, wala
Divide and
pa niyo
maximum.
mugin. Ha? Ano i-divide?
Oh, ano Sir Ansi? Subscript or like M times C?
Time iton ha, M times C. Dito niya subscript. Goodness. Kang palakitaan, valuehan C is the distance from the fiber being considered to the neutral axis on the section where you want to solve the maximum, the flexural stress. Kay maximum flexural stress man bibiling. So adto nga section where the maximum moment occur. Ano man nga fiber ang i-consider, Mr. If you are trying to solve for the maximum flexural stress? Ano nga fiber ang aton ginko consider? Okay, considering nga kita nga ano nga section, maram nakita ko na ano nga section. The section where the maximum moment occur. Dakang ginko kuan, ginko consider. Now, ada nakitahan an section. Hain naman nga fiber aton ginko consider to solve for the maximum flexural stress. Mr. Du,
An outermost fiber, sir.
outermost fiber. Okay? But, again, kaya, before we wrap up, let me, clarify. The outermost fiber, that's correct, pero, that's only, that's not always correct. Okay? I mean, correct yeah, pero half correct lang. Charot. Kaya okay, for rectangular beam, that's correct. Pero what if may dakita na sugad nga kuan? Kana? Oh, maresyo ini nga topic talaga. Nag-i-enjoy ako ini nga topic. Kay damo it possibility. What if the section is like this one? Nasugadan imo beam, sugadin yan itsoran imo beam. T section. Of course, the centroid of the T is somewhere here. Di kita maaram kung ada dida. Basta, diri iya dida hit but ngaan talaga. So, this is your neutral axis. Neutral axis. Okay, the outermost fiber are this fiber here and this fiber here. Question, Mr. Which fiber, let's name this fiber A, tas adi nga fiber B. Which fiber ha, ini nga fiber, okay, which fiber will be subjected to more more flexural stress? Hanit mas stress. Is it fiber A or fiber B?
And most further from the neutral axis, sir, and B.
Why, Mr.
Okay. Based sa formula, sir, niya, tawagin, directly proportional. Meaning, kung
Very
mas
good.
dako niya
Directly.
value, yes, sir.
Continue, Mr.
Mas dako niya value, sir, madako gyapon stress.
Mas dakon valuehan
And it's C. And
Mas
value
dakon
and C.
valuehan C, mas dakon ang valuehan FB. Di ba?
Stress.
Or revise your definition. Hain nga si Tim tukuhaon. Nakang kakangina outermost fiber. Which is only true if you are dealing with a rectangular beam. But if you are dealing with, say for example, this type of beam, ano nga si Tim pipilion? Ano nga
And
fiber Tim pipilion?
furthermost fiber, sir, from the neutral
Okay,
axis.
very good. Okay, so yung pilion nga fiber is the farthest fiber from the neutral axis. May it be in compression or in tension. Wala kita pakialam kung tension ito niya or compression. Okay? Basta it pinaka-farthest. Okay? Pinaka-herayo hit neutral axis. Amo ito yung pipilion. Okay. Any question before I end my discussion? Let's end our discussion here. Wala ipakita sample problem ha. I-discuss pala natin ang concept hindi nga formula. FB is equal to MC over I. Okay? Any question? Hello?
Oray na ada,
May
sir.
bakwa.
Malaki lang si Bibi.